In this video, we'll look at the binomial interest rate tree, which is covered in the CFA Level 2 syllabus under fixed income. And this is part of the arbitrage-free valuation framework, where we can actually use the interest rate tree to calculate the no arbitrage value of a bond, okay, or we can use it to price interest rate related options. Now, all the rates that you see here, okay, as an example, is based on an interest rate volatility of 15%, and all the rates here are 1 period forward rates. And of course, the rates can either increase or decrease after every period. Okay, so let's say, for example, if the rate goes from 2.1% to 5.2378% and 9.448%. So what this means here is that from period 0 to period 1, the 1 period forward rate here, starting from time 0, is 2.1%. So this can be used to discount the cash flow in year 1 back to year 0. And then from, let's say, if there is a cash flow in year 2, we can discount it back to year 1 using a discount rate of 5.2378%. Okay, and from year 2 to year 3, the 1 period discount rate is 9.448%. So this rate can be used to discount the cash flow from year 3 to year 2. Okay, so that's what these rates are. They are all a 1 period forward rate. Now, of course, the rates here are modeled based on a log normal distribution. Okay, so that's a log normal distribution. And of course, the risk neutral probability of an up move and a down move are both 50%, okay, at every branch. So it's all 50, 50, 50% and 50%. And the distance between two adjacent knots is 2 standard deviation. For example, let's say for this knot here, 3.8803%. If you are given this knot, then you'll be able to calculate the knot, the value in the upper knot here, which will then be 3.8803% multiplied by e to the power of 2 times 0.15. Okay, that's 2 standard deviations there. And of course, if you know the value in, let's say here in the lower knot, which is 5.1852%, then the value in the upper knot here, in the which is in the middle here, will be based on 5.1852% times the exponential of 2 times 0.15. And for the value in the high knot here, HH knot here, so this will be 5.1852% times, if you are taking from the lowest knot, so there will be like a gap of 4 there, so that's e to the power of 4 times the standard deviation. Or you can actually take 6.9993% times the exponential of 2 times 0.15, okay, because this is also 2 standard deviations in distance. So of course, the interest rate tree has to be calibrated, okay, it has to be calibrated to the current term structure so that it reflects, okay, the market, okay, or it reflects real life values, okay, so it has to be calibrated to the current term structure. So how do we know that it is calibrated correctly? So when it's calibrated correctly, the PV of the cash flows using the tree, which we call the no arbitrage value, that's the output from this model, okay, when you evaluate using this tree, okay, and it should be equals to the market price or the market value of the bond, okay, and we usually refer back to the benchmark bond, for example, like a government bond. Okay, so this methodology of then when we use the interest rate trees to discount backwards, okay, is what we call the backward induction valuation methodology. Okay, but that it will be for a different there's another different area to cover. Okay, but what we are concerned of here is how do we model or how do we generate this interest rate tree, and how do we calibrate it to reflect the current term structure, okay, or the current yield curve. Alright, so to kick off, we will first create a sample of par rates, okay, and we'll do it for, of course, 3 periods, okay, year 1, year 2, and year 3. So let's create an underline there. Right, then we'll have the par rates. Okay, so par rates are basically the yield to maturities of government bonds, okay, and why do we call them par rates? Because at that point, the price of the government bond is equals to its par value. In other words, the yield to maturity of the bond is equals to its coupon rate. So let's say, for example, we have a 1-year par rate, a 2-year par rate, and a 3-year par rate. And I will just say the 1-year par rate is 2.1%, and then the 2-year par rate is 3.3%, and the 3-year par rate is 4.5%. Right, so I'll just keep this to 4 decimal places. Okay, now in other words, if you have a 2.1% par rate, that means for a 1-year government bond, okay, the coupon rate is 2.1% and the yield to maturity is also 2.1%. So I'm assuming that this is payable annually, okay, for simplistic purposes. And then for the 2-year par rate, the coupon rate will be 3.3% and the yield to maturity will be 3.3%, and the price is equals to par. Same thing for the 3-year par bond. Okay, the coupon rate is 4.5% and the yield to maturity is 4.5%. Now, why do we use par rates? Okay, or why do we even look at par bonds? Okay, so from these par bonds, we are going to use the bootstrapping process to obtain the spot rates. Okay, and of course, it's convenient to use par bonds because the price is equals to par. Okay, something that we can quickly link to. Okay, and once we get the spot rates, we can use the spot rates to discount single cash flows or zero coupon bonds. So of course, what we want to get here, of course, is the spot rates. Okay, so that's what we want to get from the bootstrapping process. Now, of course, to make it simpler, I will calculate the discount factor, okay, from this spot rate. Okay, and later on, we want to calculate the forward rate as well as a form of comparison once we get the interest rate tree. Okay, so with that done, let's quickly generate the spot rate. So in this case, for the first year, it's usually very straightforward because it's only a 1-year bond. Okay, there's only one payment at maturity in 1 year's time, which is the par value plus the coupon rate, and then you discount it back to time 0, and then the price is equals to par. Okay, so of course we can assume par is $1 or par is $100. Okay, that will be easily done. Okay, so with that, we can easily determine that the spot rate, the 1-year spot rate, is equivalent to the 1-year par rate. Okay, so I can easily set this equals to the 1-year par rate. Okay, and we can show that this is correct as well. Okay, and the discount factor will be 1 divided by 1 plus the spot rate, and then raised to the power of the period, which is 1. Okay, so this is the discount factor. Okay, we will leave forward rate for later. But just to show that we are correct, let's calculate the PV of the par bond. Okay, of the par bond. So that will be based on, let's say, if I'm using 1 as my par value. Okay, so my spot rate, or my coupon rate will be 2.1%. Okay, at maturity, and then we will divide by 1 plus the spot rate. Okay, and then raise to the power of the period. There's only one cash flow there, so that will be 1, which is the par value. So it shows that in this case, okay, that 2.1% is the spot rate of this 1-year par bond. Okay, so of course it's just validating. Okay, we actually don't have to show it. Right, okay, but the next part, once you move to the 2-year par rate, the story is different. Now we have the coupon rate is 3.3%, okay, and then the yield to maturity is 3.3%. Now we know the spot rate in the first year is 2.1%. So what should the 2-year spot rate be so that the PV of the cash flows is equals to the par value, which is 1. I'm assuming is 1 here. So we can use a very simple formula. So I will just take equals to 1, which is the par value. Okay, then we will plus the coupon rate. Okay, in this case it's 3.3%. And then we divide by the price, okay, the price which is 1, or the par value. Okay, remember this is a par rate, so if it's a par rate means the bond's price will be equals to par. And then what we'll do is we will minus the coupon rate. Okay, we minus the coupon rate, then we multiply by the total PV, okay, of the total sum of the discount factors from the previous period. So in this case, prior to period 2, there is only the discount factor in period 1. Okay, so I'll just click on cell B4, and then I'll press the shift. Okay, I'll press shift column, and then it will highlight B4 again. Then I'll just close the bracket. Okay, so basically this C2 times sum of the discount factor will be the PV of all the coupons, okay, prior to the current period. Now, of course, to make things safer later on, I will need to lock B4. Okay, so I'll just press F4 to lock it. So later on, when I copy the formula over, it will move in the right way. So once we are done, okay, I'll just close the bracket, okay, to cover the denominator. So once we have this, we need to, of course, convert this to an annualized rate. So this is a spot rate for the second year. So I'll just put a bracket here, and then to the power of bracket 1 over the period that we are going to calculate the spot rate, and then minus 1. Okay, so we are done. So this is the spot rate for the 2-year period. Okay, 3.32%. Now, with everything done, I can just copy this over. So the formula should follow correctly, but we need to calculate the discount factor for period 2. Okay, so I'll just copy this over again. Okay, and then we have the right number, right formula. Okay, so that it will be 4.5746%. Right, so we are done in this case. So just populate this discount factor. Now, to get the forward rate, okay, just for our checking purposes, so the 1 period forward rate starting from today is also equals to the spot rate. Okay, so we'll save our time there. Now, the next part here is to get the 1 year spot rate, the 1 year forward rate starting in 1 year's time. So to get that number, I will take 1 plus the 2 year spot rate, okay, and I will raise this to power of 2. Okay, and then I will divide by 1 plus the, of course, this 1 year spot rate here. This 1 year spot rate here, which is 2.1%. Raise it to the power of 1. Okay, so this will give us the total amount. Okay, now we just need to minus 1. Okay, so that will be our this is our 1 year forward rate starting in 1 year's time, which is 4.5547%. Then I'll copy this over, and then we get 7.1297%. Okay, so this is the 1 year forward rate starting from each of these time period. Right, so of course, if you want to double check whether these spot rates are actually correct, you can easily do so by taking the sum, the PV of the cash flows for that period. So for example, if I'm doing it for, let's say, the 2-year bond, right? So what I will do, if I want to validate, okay, I will just take the coupon rate, okay, multiply by the sum of the discount factors up to period 2, okay, and then for the par value, which is 1, there'll be 1 multiplied by the last discount factor, and this should be equals to 1. Okay, that's how you know you are correct. It should be, the price should be equals to par. Okay, and of course, if I were to copy, if I would lock this in, and then I'll just copy it over, you should get 1 as well. Okay, so this shows that using these spot rates, okay, the price or the PV of the cash flow should be equals to par. Okay, right, so we're done for this. So this is the spot rates. We'll now proceed to generate the binomial interest rate tree. So let's start with that. So the interest rate volatility will be 15%, okay, for our illustration. You can, of course, change it later on and try to change the figures. Okay, now I'm going to place the interest rate, binomial interest rate tree here. So we have from t equals to at time 0, 1, and 2. Okay, and keep in mind that these is basically from time 0 to time 1. Okay, because all the interest rates here would be 1 period forward rates. Okay, so let's there. Right, so we have 2.1% at the start. Okay, this is the spot rate. Okay, it's even the forward rate here. So I'll just place it in the center. So that's 2.1%. All right, and then of course the interest rate can go up or it can go down. Okay, so let's just put 2 numbers here. Okay, so let's say it can go down. So maybe it can go down to maybe 2%. Okay, we don't know the actual number yet, which we are going to look out for. Okay, and of course the interest rate could be higher. Okay, we will need to find that value, and then but we know that if we know the lower knot value, then the upper knot value will be the lower knot value multiplied by the exponential of 2 multiplied by the interest rate volatility. Okay, so that's the relationship. Okay, so it will be 2.6997%, but this is not the correct rate. We still have to find out the rate later on. Okay, and of course after that the rate can go up, it can go down, and same thing when it's 2%, the rate can go up, it can also go down. So let's say the rate goes down further to maybe 2.2%. Okay, so this is just our guesstimate, it's not the answer, right? And then based on the relationship, I can then paste this down. Okay, so this is 15%, okay, and it's 2 standard deviations. And then for the upper knot, okay, you can either just copy the formula upwards, okay, here, or you can even use 4 standard deviations of 2.2%. Okay, so it's purely up to you. The answer is going to be the same anyway after this. All right, so how do we calibrate the tree to the current term structure, okay, which is the results that we obtain here, the spot rates and the forward rates. So the condition here is very simple. Okay, when you PV the cash flows of the benchmark bond, which in this case is the par bond, the value that you obtain from the tree must be equal to the price, the market price of the bond, which in this case we know is equals to par. Okay, I'm setting the par as 1 here. Alright, of course, to make it easier to illustrate, I will just assume that from now on, okay, I'm going to use a par value of 100. Okay, I'm going to use a par value of 100 in this case, so it's easier to illustrate, it's nicer to see than using 1 as the par value. Okay, so just keep that in mind. So just color it as green here. So let's start. Okay, I'm going to do it for period 1 and then I'm going to do it for period 2. We are going through the process of calibration here. All right, let's start with the 1 year par bond. Okay, so I'm going to start with the 1 year par bond. Okay, we're gonna use this bond as our starting point. So we have time t, okay, and then there's time 0 and time 1. Okay, so what are the cash flows of these bonds? Okay, so since it's only 1 year, okay, therefore there's only one cash flow in 1 year's time, which is equals to the par value. Okay, maybe I should just enter 100 here. Okay, so the par value is equals to 100. Okay, 100, and then plus of course the coupon. The coupon will be 100 times the par rate of the 1 year bond, which is 2.1%. So that will be 102.1. Okay, so that's the cash flow at the expiration. Now, of course, how does this translate to the valuation using these rates? So in this case, if we have a cash flow, let's just put the cash flow here. So if I have a cash flow in 1 year's time, okay, and I want to value it 1 year backwards, the only rate I can use here is the 1 year period, 1 year forward rate starting from today, which is 2.1%. So I will just take the cash flow, divide by 1 plus this 2.1%. Okay, so that gives us the par value. So we know that this 2.1% here is indeed correct because the no arbitrage value or the PV from this tree is equals to the par value. Okay, price is equals to par because it's a par bond. Okay, now so this is fairly straightforward, nothing much for us to do. Now I'm going to move on to the 2 year par bond. So I'll just copy the framework downwards here. So I will have the 2 year par bond. Okay, and this time around I'll just extend the period to 2 years. And what are the cash flows this time around? Okay, so the cash flows here would be the par value. So we'll have the par value times the coupon rate for a 2 year bond, which is 3.3%. So I'll log that in. Okay, and then I'll copy over. Okay, so of course it will run here because I didn't lock it in. So let's lock it in as well here. So let's copy over. So that's 3.3, but we have a par value. So I'll just add in the par value. Okay, lock it in again. So we have 103.3. Okay, so that gives us the cash flows for this 2 year par bond. Now I'm going to discount this using this interest rate tree. Okay, using this up to this part of the tree. So I'm going to follow the sequence here. So I'm going to just copy the cash flows over. Right, we have 103.3. Okay, 103.3. Then we have 3.3 here in this case. So I'm going to leave it there. So from 103.3 and I'll discount it back 1 period backwards. Okay, I'm going to use the 1 period forward rate starting in 1 year's time, which is 2.6997%. So that's equals to 103.3 divided by 1 plus the upper knot rate. Okay, so that's 100.5845. I'm going to do the same thing here. I'm just going to edit it, copy downwards. Okay, so we have the same. Okay, 103.3, but this time we discount it using this 2% rate, which is not the right rate. we're going to calculate what this is in a short while. Okay, so this gives us the value at each knot, okay, the value at the high knot and the lower knot. And lastly, to get the value at time 0, I'm going to average out the two values here. Okay, I'm going to average it by multiplying it by 50% and 50%. Okay, that's the probability of an up move and a down move in interest rates. Right, so let's do it. So I'm going to take this is equals to, okay, bracket 0.5 times the value if the interest rate is high. Okay, because I can just times this C27, okay, and then plus 0.5 times the value if the interest rate is low. Then we add in the coupon 3.3, okay, and then the whole thing will be discounted at the rate at time 0, which is 2.1%. Okay, so that gives us our value. Now this is definitely wrong because by condition, if it's a par bond, the price must be equals to par, which is 100. So how do we actually so what we need to do now is I need to set this to 100, and I need to know what rate should this be, what rates should this be, so that the value here is equal to 100. So I can use the goal-seek function. So if you click the data tab under the what if analysis, there is a goal-seek function here. Okay, we'll set cell B28 to a value of 100, so that's the par value, which is our target here. And what do we need to change? So I need to change the interest rate in the lower knot in period 1. So by changing this, it will update the interest rate in the upper knot. Okay, so let's click OK. So our final result here is 3.8003%. So this tells us that for the arbitrage-free value to be equals to 100, okay, for the calibration to be done, the rate in the lower knot here has to be 3.8803%, and the rate in the upper knot here will be 5.2378%. Okay, so we are done with the 1 year period. Okay, so the interest rate in the 1 year period. So now let's move on to the last period, which is the second period. Okay, so I'm gonna just copy this downwards. Okay, so this will apply for the 3-year bond. So that's a 3-year par bond. I'll extend this to 3 years. Okay, and then the cash flows, I'll just pull it over. Okay, but bear in mind that the coupon rates are different now, so it should be 4.5%. Okay, so that's 4.5. Copy this over. Okay, and then this you have to add the par bond, the par value. Alright, so now we're going to repeat the same process. I'm going to copy the cash flow in the final year. So that's 104.5. Okay, and then I'll just remove this. So by doing that, I'm going to just take this formula. Okay, I'm just going to copy it over here, so it will just discount, but the rates are out, of course. So this just change it back. So make sure that we take the final cash flow. Okay, so I'll just start fresh. I'll take the final cash flow here, divide by 1 plus the previous period's discount rate, which is here 4.0087%. Okay, and then I'll just copy this to the lower 2 knots here, just making sure it's discounted by the correct rate. Okay, we have this formula, okay, which you can copy from the previous part. Okay, or you can redo it again. So this, let's say if I redo it again, that's 0.5 times the value in the upper knot plus 0.5 times the value in the lower knot, and then we add in, not forgetting to add in the coupon. Be careful here, the coupon, just make sure to lock it correctly. So I'll just put D $31 and then divide by 1 plus the previous period's discount rate. In this case, we found earlier is 5.2378%. Then done. Okay, we have these values here, so let's copy this downwards and making sure that it's still sticking to the right coupon, okay, which is 4.5 and discounted with the correct rate. So we're done here. Let's just copy this to the value in not 0. Okay, making sure that it's attached to the right rate and the right coupon. Okay, so we have our value here, which is not correct. So for the 3-year par bond, the price must be equals to par. So what should this rate be? Okay, series of rates be, so that you get this as 100. So again, we'll use goal-seek. Okay, I'll just set the values. Let's say the cell in B35 here to be equals to par 100 by changing the cell in D16. Okay, so let's click OK, and we get a final result. Okay, so the interest rate in the lower knot, LL knot here, which is 5.1844%. This should be 6.9982%, and the the rate here will be 9.4465% in the highest knot. Okay, so that is in order for the PV to be close to par. Okay, so of course there is some residual numbers at the back there. Okay, but this is the closest we can get, okay, using the goal-seek function. So that's how we actually do it. Okay, for we call this a 3-period binomial interest rate tree, because I can use this to value a 3-year bond after this, or I can even use it to price let's say a 2-year cap or floor. Okay, so it's quite useful in this case. So the calibration here is important so that the interest rate reflects the current term structure. And after this, when we do our valuation, the value that we get here is what we call the no arbitrage value. Okay, that means at that if the price is equals to the no arbitrage value, then arbitrage opportunities will not be available, or it will not be possible. Now, of course, you will note that if you keep changing the, let's say if you want to change the volatility to 20%, then of course you will have to redo the whole thing again. You have to use the goal-seek for each of these 2 knots. Okay, now of course you can make it easier by, let's say if you can use a macro. Okay, I can actually use a macro. So let's say if I click on the developer tab, let's say if I were to click on record macro. Okay, I'll click on record macro. So let's say I'll change this to 20% first, okay, so that we can see the result. So I'll click on 20% and then I'll just click on record macro. Okay, and let's say the record macro here is to calculate the binomial interest rate tree. Okay, so I'll just click OK here, and then we'll just do what we did earlier. So I'll click on the data tab, I'll click on what if analysis. Okay, I'll click on goal-seek and make sure that I change the value, okay, for the 2-year par bond here to be equals to par 100 by changing the cell in C15. Okay, and click OK. Once done, then I will proceed to do it for the next one, which is for the 3-year par bonds in cell B35. Set this to 100 by changing the cell in D16. Okay, then click OK. So once we are done, we'll stop the recording. Now let's say if you want to call the macro using a button, for example, you can just click on the developer tab, and under insert you can just insert a button here. Okay, let's call it let's attach it to calculate BIR, which is our macro name, and click OK. And let's say I will call it generate. Okay, so every time you change a value, let's say if I change the par rate to 2%, okay, and then you want to generate the tree again, you just click generate. Okay, and then it will automatically calculate the rates so that the price here is equals to par. Okay, or if you want to reduce the interest rate volatility and click generate, okay, it will repeat the same process again. So that's how a macro is useful. Of course, we could do other things. We could use VBA to generate the tree. Of course, they'll be more flexible and more powerful, but the purpose of this tutorial is just to show you how you can easily replicate or generate a binomial interest rate tree on your own by just using goal-seek, okay, and of course using a macro to make it repeatable. So hopefully you find that session useful. Okay, you can do it. You can generate an interest rate tree on your own. Of course, if you need to generate it for longer periods, then of course it'll be more cumbersome. But if you're just generating it for 1 period, 2 period, or 3 period, okay, it's quite straightforward to actually extend through.